6, 5, 4, 3, 2, 1. I assume I'm streaming, and I am back to actually perform the breadth first crawl of a site using Python in my PyPy. When I say PyPy, by the way, what I'm saying is PYPI, Python Packaging Index, which is this location, which is where everything that you get when you pip install Python comes from. So if I were to search here for pipulate, you will see the stuff I've been releasing. It's up to its current version, I believe, 3.54. That always reflects what's in my file, my setup.py file that I've been showing you along the way as we've been developing. So actually this is the pipulate one, so I can drop into the shell of pipulate, cd up one directory, and vim setup.py, C version 3.54, which is what's now currently out on PyPy. So when you pip install pipulate, it gets right up to the latest. So that's a slight tangent to explain what I mean when I'm using my tools. This is my tool, which can be your tool as well. When you're in a Jupyter notebook, you just go bang pip install pipulate, and it'll be on your system. There might be some other dependencies you have to install, but it'll report it, especially with how I've been somewhat aggressively expanding pipulate's capabilities recently. I've been adding things here and there, like pickled built into the standard library. What else? Cycle, standard library, beautiful soup built into Anaconda, shouldn't be a problem. So actually everything's pretty good. If you are like me and are running Python in Jupyter Notebook via an Anaconda install, you should be just fine. So this is a little bit hairy to look at, so I will do kernel, restart, and clear output. And now that stuff is built into pipulate, I hardly need any of this, and it might be time for me to just do a new notebook. Get rid of the unnecessary stuff, leave enough that's interesting for people who are following along, and I don't want to erase history. This is executing a one-page crawl, and that was crawl.ipynb, but I think it's important now to clarify that that was a one-page crawl. Close and halt so that file locks are off of it. We go into the other tab here, and we git move crawl.ipynb into crawl page.ipynb. Git status. So you see we changed it, and Git knows about it. So git commit renamed crawl to one pager. Push, not 100% technically accurate in the description, but it gets the point across, because the next thing we're about to do is very different. It's not a one-page crawl at all, but we are about to build a little queue and crawl all the pages that we find on a one-page crawl and get back a list of all of the links. Whew, this is deep breath time, so, I got everything out of this that I need to get out. There's nothing special built into the Python standard library that we need to use. There might be special things in the standard library, but none that we need to use right now. We do want to be in my Python SEO repo, and we're going to make that next file. It's always nice to have a next file. I'm going to get rid of this from memory, so all we do is shut down. We don't need that in memory. There's no real harm in having it, but it's, have nothing more running than what you're working on. Let's just good practice. New. Line 3. Get rid of distraction. Those shortcuts showing. Oh, one thing we do need, and it usually has me opening up opening up an old notebook anyway. I'll use my crawl page because I know it was in there. It's always in my last bit of code. It's too much to type this just to bring pipulate in. Again, from the sibling folder is what we call it. Close and Alt. So pipulate is now in memory. Run it again, and it just says congratulations once. Okay, so who shall we crawl? I don't know. New York Times, they've been charging for their site forever. It's a decent one to start with for an exercise like this. We just grab their home page, close out of it, don't need that tab open anymore. Site equals. So there we have it. Now we do links equals pipulate.crawl site. How nice is that? On-site links and off-site links, two separate, already parsed lists. And it occurred to me, by the way, since we are really crawling a variety of sites out there, and they know it's Python, we should take some moderate defenses against it being so instantly recognizable as Python. Most sites won't have a problem, but occasionally they will. And I went through all this effort here, right here, on the servant function to be able to cycle my user agent, that it seems to me I should be able to do that up here as well. And now at least I have a different user agent being fed on each request, so it looks a little bit more like a genuine web browser, which we could be using, by the way, and that's a separate story. We're going to get to crawling with Chrome instead of the Kenneth Wright's request object in a short time, not on this video, but in a short time, YouTube tutorial-wise. And just in case you're wondering, kernel, restart and clear output. It's the only way to be sure that the edits you made are really good in a REPL environment, because REPLs are so good at caching everything. See how little code it is? And once this is just the single line import pipulate, that really replaces all that above stuff. So this one page site crawl, just so you know, is this much code, which could absolutely be replaced by this, right? And we don't want to do the import pipulate right now because that above code is loading it a different way. Boom, boom, boom. So the user agent cycling is now in action. And when I talk about that cache, the persistent, okay, so we're going to be doing some persistent objects on the hard drive side by side with our code, so that as we crawl, if the crawl gets interrupted, we can pick up where we left off. Everything's on the drive. So now that we have this object, we're starting to create an algorithm in our heads. I sometimes re-execute stuff like that just to make it easier to look at. I'll put this up in here. Get rid of these because we don't need to look at all that. We got links here. And we're going to be accumulating a big bag of links as we travel on site. We're going to be traveling on site links and accumulating more on site links as we go, accumulating and depleting, going from a list on the left into a list on the right. So there's going to be the concept of unvisited and concept of visited. So housekeeping wise, is that how you do that? I guess it's more like this. Housekeeping wise, there are a few things to consider. One is that housekeeping will be pickled and persistent. 2, housekeeping will use sets for deduplication or duplication prevention, what have you. And 3, there will be 2 housekeeping lists for crawls, unvisited and visited. And 4, we will be accumulating a list of offsite links as we go. And in a data structure regarding a list is enough. A simple list of offsite links is enough. No, where it was found necessary. URL necessary. Although that might be nice for double checking things. ZG, it's time to add offsite to my dictionary, and lowercase URL ZG, which will all be in my dictionary. Okay, think this through carefully and then do it. We don't need to really look at the links. That's just distracting. We know that that's sitting there. And concept-wise, we want to, these are all unvisited except for the home page. So accumulate dot persists. Persist. We want it to persist. Links 0, which is the unvisited on-site links. It's going to be unvisited, not PKL. And we are also at this time going to create another one, but it's going to be an initialized empty list, which is visited, which will only include, actually, we can put one in there. It is the site, because we know we visited the home page. So we can initialize it with 1. And we'll do a before and after. Now I'm going to remove everything that has PKL in there because unnecessary. Here's everything that's in that directory, and it leaves behind the credentials and the default. Those two are outside, delete because they spelled out pickle instead of PKL. I, by convention, use PKL, so it's easy for me to delete out all the work I've been doing. And I am, of course, still on Untitled. I think it's time to rename that into multi-page crawl, because it'll be a multi-page crawl, but it'll only be one deep. So I'll execute that, and now we can go over here and look at that again, and you can see we have unvisited.pkl and visited.pkl. And I can actually visit each page and extract the links and drop it in here, so long as, oh, this is interesting, I am dropping it in as a list. I do believe I want to do it as a set. Small detail, but still important. And it's absolutely fine to repickle an object. It'll just write right over it. And it's just a different data type in there than it once was before. You might be able to see the size difference. There's unvisited.pkl 11937, unvisited.pkl 6. So there's probably a lot of duplicate URLs in there. It can tell me. I can confirm that by doing the length of links, right, 219. But then there's also the length of the set of links. This is deduped because sets is a natural deduping. Remember, 110. So after it dedupes, it goes from 219 to 110. So we don't want to visit any of these pages more than once. So we definitely want to drop the set into there. And that's kind of just initializing our housekeeping. Now, people say go with crawling packages, pre-made crawling packages in Python instead of doing this. But I say that's just so much overhead when it's so little code to do a simple crawl that you have 100% control of. Why not just do it yourself? So we now are going to visit each page from here, extract the links, and add the whole set, because you can add sets to existing sets. And it's in memory as it goes, but I'm going to make it load off of the drive after each time. This is actually kind of interesting and hard to articulate, but let's do a simple for URL, because they are URLs in, and we will load it off of the drive. Populate.persists unvisited.pkl print URL. And you'll just see all the links that were grabbed off of the site. Okay. We can think through issues in here, because there are in fact hashtags and stuff in these occasional URLs, and query string results as well, which all bring up their own particular issues, but we're not going to worry about them too much for now. But you can see we can visit each visited one, and yeah, right. Each time we visit it, we want to load unvisited equals manipulate dot persists. It's time to put unvisited into pkl unvisited. Ooh, interesting. Unvisited file. You know, it just makes it harder to read, doesn't it? Ugh. You know what? Sometimes a string is better. So we'll have it in memory for each trip through. We're going to see just how much loading that whole file off the drive for each of these URLs costs us. And it's a local machine cost. There's really no visiting to the outside world going on. As you can see, it was mostly instantaneous. Now we want it in memory because we're going to be adding, let's see, we're going to be adding to visited, but we're going to be writing back, popping off, unvisited, set remove, removing from a set, Python, delete item from set. Set.remove. You know, you almost don't have to go in, but I can see it's going to be set.remove element, and then it's not going to be in the set anymore. Let's give it a try. Unvisited.remove the URL we just visited, and then make it persist again with a slightly smaller set. And it should be empty by the time it's done. That is, the list on the drive should be empty by the time it's done, because it will in fact be depleted. Now links will still be populated, so I can even redo this and start over without recrawling the site at all. I do the test like that. You can see it's considerably slower. And now if I try to execute that again, it won't even run because I have depleted the list. See, exactly as I had planned. So see how easy this stuff is when you just, think it through and cut out as much of the API verbosity, all the wordiness in APIs as you possibly can. So I can actually add back into the list stuff it has not seen, but which is also not in the visited list. So let's see if I can do this while not confusing myself to heck. I'll put in a bunch of more boxes just to move that up to a nicer place on the screen to look at. So for everyone in the unvisited, we deplete it, it's depleted. So if I did this again, it'll run again. But it won't run a second time without populating unvisited again. See, empty. So that predictability is exactly what we wanted to see. But now we have the visited concept. We're adding. And to add to a set, you just simply add to it. Lists you append, sets you add. So unvisited equals populate persists visited, and that'll get it into memory. And each time we visit one of these, instead of a remove, we go visited equals, oh wait, no, it's just visited.add. The URL we're looking at, and then we make it persistent again. We tell it to persist. Populate dot persist visited to visited.pkl. So visited will actually begin to populate as this goes, so we know what we have visited. So we're going to have to delete that once in a while. We're going to have to reset this a lot because we don't want the visited to interfere. I just got to make sure that the code is right. Of course, we do need to repopulate it this first time to make sure the code is right. No errors getting reported. And this little bit of code will in fact blank the visited as well, so it's going to be some easy testing. But we're going to be putting a where condition in, because as we do all this, this is really just the housekeeping, because what are we doing? We're crawling. This is a little difficult to look at because unvisited and visited are so similar. It seems like there should be an underscore in there to really make a difference. No, that makes it look even more similar. It's visited. Okay, so this is how we'll go for now. But if URL, see, we don't want all the action to happen until we know we have successfully visited a site. New links. There's a concept of new links, and we'll be adding them as a set onto unvisited as we go. It's all about order, sequence of operations. This is where things can go wrong if you don't do this stuff right. I'm going to do it at the bottom and then think through where it actually belongs. Oh, see, everything is committed back, right? Already I almost made a mistake. Everything's committed back to the drive. So we need to add to unvisited before we make that persistent. So we remove the URL, but we are going to say new links equals populate dot crawl. Oh, yowzers. The URL that we're on, and then we're going to add to the unvisited. And we're going to have to do it an item at a time because we're going to have to compare whether it's already been seen and visited. For new link in new links, and remember we have to grab the 0 item because it's on-site and off-site. Unvisited.add new link, but it has to be as a result of a condition. If new link not in visited. And so you see order of operations again. Visited already has to be open but not closed. We don't want the URL that we're actually on to be re-added, so it has to be in there by the time it's done. And it persists the two things at the end. It makes sense that you make the two things persistent as the last step before it's done. And if new link's not visited, yeah, this is looking pretty good. It's also considerably more time consuming because this is in fact a HTTP. This is a crawl that I put in there. Where's that crawl? Here. Whew, okay, I guess I just do it. That was fast. I never even got to the print URL. Something is wrong, of course, at the blank stuff. Okay, name unvisited, not defined. I'm using something before it's unvisited, data link. EISI. UISITT. Spelling, I bet. Nope, not defined. Unvisited. A little bit better, but look how slow it's going now. This could go on for a little while, but it should only be able to visit each URL it finds once because the visited is getting longer and longer. Now, we're going to be enumerating, we're going to be listing the number of links that we find here. This is a crawl. This is a one-click depth crawl that's occurring. And for anyone who's done this sort of stuff, you should know that a one-click depth crawl is actually an enormously larger set of the site than most people give it credit for. Even the version without the trailing slash is considered. I wonder if it's going to be printing it, whether or not. Yeah, it's going to be showing us the duplicates here for every iteration, whether or not it ends up adding a new one. So, hey, look at that. It finished. So if we go over here and we look at those file sizes again, we should find that, hey, yeah, it's not exactly what I was thinking. I thought that was going to be much bigger, and this was going to be much smaller because we're committing as we're going. But now we can take a look at these things. They keep getting recreated, but they should have their values at the end of that week. Those should be directly inspectable. Visited, long list, unvisited. Well, unvisited. Maybe I'm wrong. Did I spell it wrong everywhere? Yeah, I did. I spelled it wrong everywhere. And that probably is what's getting me. And that would totally not work. And that would explain that. So anyway, kernel, restart, and clear output, because those kinds of errors get through on a REPL environment, on eval print loop. Oh, just got a little battery thing. I have my power supply here, so I just scramble to plug it in to keep this thing going. There we go. Okay. So we redo. That performs the first page crawl. This creates those first two pickles. It sort of blanks them, puts them back at their initial values. Visited, you can see, is really small. Unvisited has some size to it. Visited.add. Okay, so I don't like the print statement being there. I only want the print statement to occur if that is met. So every time we see a print URL, it's one that has been added to the visited side and has not been seen before. So that's pretty good. That'll be a good indication. I also want to see how many we've looked at. So that goes to the trick you can do for I, URL in pickulate persists unvisited. So that's the initial list. Yeah, wow. Interesting. So it's only going to go through that, but each time through. Yeah, okay. Put the word enumerate around this. And now we have a counter. Print I, URL. Ugh. This is where you want to be careful. I mean, we're not hitting anything hard, but that's too much printing. I just want to hit stop because it's not. It's ugly. It's a nested list print is what's going on there. And this is also what makes Jupyter Notebook performance. So you never want to do anything that does runaway print statement in Jupyter Notebook, or you're going to be facing this situation. I got to clean that up in memory as quick as I can. And there should not be situations where it can print that much. That is a strong indication that something is actually wrong. So what we're going to do, we can do it, but we're going to restart the kernel because this is just too slow. Start and clear output. Jupyter Labs might be a little better at that sort of thing, but right now, runaway print statements are the bane of data scientists' existence. This terrible Jupyter Notebook performance. That print statement. Beware. Come on. Kind to your Jupyter Notebook. Restart and clear all out. And I wonder how this is affecting streaming too, because resources are being divvied out. Could this be any more painful? Okay, I think it's taken. We'll look to see that flash. No, I clicked it. Restart the kernel. Ugh, you know what? We're in control. Jupyter Notebook is not in control. I just quit it through the console. This is a dead tab right now. Jupyter Notebook will spin back up, and then I'll do a refresh on this tab, and performance will be back up to where it's supposed to be, and we will continue this tutorial to its successful completion, because it's a good one. Oh, and did I run Jupyter Notebook twice? Wouldn't that be just perfect? That little one is concerning. I might have closed the wrong one, which might break the connection to the open tab. Isn't live streaming wonderful? One little misplaced print statement, and you're dead in the water. Do a refresh on that, and I see it's dead. But at least I have some responsiveness of the browser itself, which is an important thing. Resources in the background are being cleaned up and deallocated, and now this should reallocate them. Running Jupyter Notebook was none too quick when we first started our session this morning either, so nothing new there. Yay! We're back. Takes out of that one. Do a refresh on this one. Do a refresh on this one. Hourglass is an indicator of it still working. Doing that refresh is doing the spinning up of the virtual machine that's tied to that tab. And there, it's finished. Now, a kernel restart and clear output will be reasonably speeded. Will be of a reasonable speed. Is that reasonable? I don't know. If we run this one, that does the original pipulate import. Again, not the speediest of all processes. Come on, come on, come on, come on. I do it one more time to get rid of the double. Congratulations. I load that into memory. I create these two objects. And now I remove this, least I create havoc again. And if not, but that doesn't solve the problem. Each of these new links should not, maybe, yeah. If new link not invisited, then we add it to visited. And then visited needs to be written out right away on every single file. Geez, okay. It's a scope thing, because we keep loading visited off of the drive. We need to commit it back into the drive, and We remove it here, we add it here, and that commits it. It seems like it's either the right logic or awfully close to it. We persist unvisited every time we remove, so it's the same out then. Visited gets added there, but this is a sub thing where we definitely want to update visited. Okay, I'm going to run this. It has no print statement, but the size of those files at the end should be very telling. It does have an end, because I remember when we were printing it, we could see it as it went. So this is not a waiting folly. But we can always look at those file sizes and see visited is getting larger. Unvisited is still 6461. It is a different number than before, which is what we want to see, because unvisited is going to get bigger and then gradually shrink as the things it finds get put into visited. So these patterns are exactly what we should want. This struggles to stay the same size because new URLs are being found, but this one definitely gets bigger all the time. There, that's getting smaller, that's getting bigger. Kind of a delight to see it this way, even though over here it's just an asterisk. File IO. And we'll know that it's nearing completion as unvisited starts to actually decline 5.4 to 5.1 to 4.9. It's running out of unvisited links. Wonderful. Numbers are going in the correct direction. Taking longer than I had hoped. But that visited list of URLs is going to be interesting at the end. That is going to be a one-click depth crawl of the whole a one-click depth crawl of the website. Look, that's dropping to 3.8. This is going up to 78. Nice. Love it when a plan comes together. We should have probably provided some visual output, but when you know what you're doing, you just know what to look for, and you lean into the strengths. And look, visited dropped to 0. That's very interesting. Nope, that was just a file IO fluke. I hit it while the file was open, but it is definitely approaching the end here. Fewer and fewer unvisited pages that it's never seen before, as URLs are being pulled out of the unvisited, going into the visited list, and still, new URLs that haven't been seen before are becoming less frequent. And I'll tell you when the asterisk is going to go away on the other tab over here. We'll come back and I'll go, watch, this asterisk is about to disappear. Doing it old school. So, of course, the relationship between Jupyter Notebook and the command line and the Linux terminal command line in particular, when on a Windows machine, is what's going on here. I mean, I used to be sort of a Mac head because Macs were genuine Unix, and at least genuine Unix beat proprietary Windows any day. It's just not the case anymore when an environment like this, Ubuntu, is... Oh, there it is. Okay. Asterisk about to disappear. Ready. We're ready. We're ready to see that disappear. I don't want to flip over to the other screen and do any more LSs. I want to be true to my word. Although, of course, in a crawl, you never... Oh, there it is. You never really can tell. So, visited. Here's all those visited URLs. They're all going to be on site. They're all going to be URLs we visited. And it worked exactly like having finality about it. If there were spider traps in there, you would have... that process would have never completed. So the fact that there's such finality is proof that we've actually done what we intended to do. So when you hear the advice, oh, don't crawl a site, use Scrapey or some other scraping package, I would say to you, they're having you go through all those loops so that you can avoid having about that much code by doing it directly. Now, of course, I am using Pipulate, which has some persistence things and the crawl thing. But, I'm in control. The Pipulate code is mine, so of course I can do anything I want with that. But now I have the ability to, point, this to a web page. I'll probably turn this into a function in Pipulate to just get all the, it's a one-click depth crawl. And one of the other things I'm going to be doing is, I didn't do it on this pass because I wanted to see the finality of that to occur. But I'm going to be collecting all the offsite links as I go so I can examine those offsite links looking for different things I want and need to look for. If I try to print the unvisited, you'll see it's an empty list. Unvisited is not defined. Oh, I went with the misspelling everywhere. Formalize the misspelling. Boy, all you people watching. Oh, and yeah, unvisited is an empty set, and visited has a length. Now, you'll be able to see a few key things. You're like, well, aren't they different types? No. If you look at the type of unvisited, it's a set. And if you look at the type of visited, it's also a set. If you look at the length of unvisited, it's 0. If you look at the length of visited, it is 1,773. So I actually visited 1,773 pages while we were sitting there, while we were sitting there continuously refreshing this. If I do one more, you'll see the final status, an uninitialized or an empty list still takes a little space as a pickle, and this grew to that size. So the housekeeping is ideal, and by pointing to the home page of a site, saying get all the links from that site, and then visit each on-site link you found and get the links from those pages and visit those so long as you didn't see them before, creates a one-click depth. And I guess I'll note that up here, right? Because I've been doing that on all these things. so that you can see what each of these files is about. This is a one-click depth crawl of website. That is an excellent place to start to wrap up this this thing, except what's of value here? We want to do this process. The resulting list is not all that big, and it's actually already stored on hard drive. So all the stuff that is important about this is kind of done. Here's a remarkable thing. So now if I do kernel, restart, and clear output, you're like, oh my God, you just did that whole crawl and you lost all that data. You're not using a database. I'm not doing any database stuff here. I'm not doing any, file opening and closing per se, except for pipulate.persist and persists. But even after restarting everything, I can say visited. I'll just do it like typing it out, right? I'll do a bunch more of these boxes so that when I do it, it's sort of in the middle of the screen. And I do visited, VISITED, equals pipulate, and I know it persists, and it is everything that we visited .pkl. Oh, you have to at least re-import pipulate, right? Can't get away from the tools you're using not being reloaded. How to reload your tools, your in-memory libraries and stuff. Okay, but we don't have to re-execute that enormous crawl to get those lists of links, those 1,700 some of links back. Bam. So let's put that in the pipulate code and call that a function, because all it has to be done is fed an initial, and it'll write over the last crawl, but that's okay. For the purposes we're doing, I'm going to allow it to write over the last crawl with it. I'll use a standard unvisited and visited, and this goes part of that. But of course, site is the input parameter, so that's pretty close to the code. Go over here. Now, I called the last one crawl, and that just gets the one thing. And that's what I want to encourage. Most people should just do one-page crawls, because I don't want them to be sitting there waiting for mysterious stuff to happen. So I'm going to call this def crawl one-click crawl. Strong nickname. One-click crawl. One click crawl. Got to think about it to use it. Set paste it in. Thing where I have pipulate, I need to take that out because it's because it's already in there, and I'm going to do it a slightly safer way than all those manual replaces. I'll just do the replace right here in the function. So it's s slash populate backslash dot long story forward slash GCC. Boom. And then we can return that list when it's done. Return, what's the good one? Visited. That's a whole list of everything you visited. I might change what gets returned later because what I'm really looking for is all the offsite links it found during that. But for right now, it seems to me like this should just about do it. I need to search for bad tabs. Yeah, of course I inserted those. Let's try set. What is it? It's tab stop. Oh, let me just look through my history because it's expand tab and tab stop. It's set expand tab, and then it is retab, and that fixes it without doing a search and replace. Now I fear actually doing testing this because it forces a reweighting through the crawl, but I'll put some feedback in each time it hits a URL, each time it actually attempts to fetch a page, because that's a time-consuming thing. And when that crawl occurs, each time the actual crawl occurs, I will print just a period, see? And then I'm going to do end equals nothing, which is going to prevent line wraps from being done. So there will be a dot going on. But since I am enumerating, right, it seems like instead of just the dot, I could print the that actual number. But let's get the number with a space after it. So it's %s, which is going to be the number, a space, and then and we're going to know the size of it, right? So %s of %s, but then it gets into the print situation. So I'm going to print the length at the beginning, and then I'll just do the I right here for the iteration. It'll probably work. It's right in the print statement. It's not traditional, but that should do it. And right here, once we know the length of, we're not going to know it because it's going to keep changing the length as it goes, and I don't want to keep re-outputting that. So I'll check it against a much smaller site, maybe my own personal site. I don't have that many pages on it. Or no, for consistency, we'll do the New York Times. But it's built in. It's built in to populate now. It shouldn't have any errors. It's now in memory. I should be able to go way down here. I'll add a few more of these guys just to push this into view, and say new links equals populate dot one click crawl against the same URL as before. Just controlling for conditions, but at least this time we'll have a little bit of output coming to us. Ready? Go. And you're just seeing the numbers appear each time a new page is being fetched. So we'll be able to see the number of total pages that were fetched. We know it's going to be somewhere close to 1,700 because it's going to visit each page, but it's going to start going really quickly because most of the pages it finds it will have already visited. Hopefully it won't make a liar out of me. But now we are actually back in that. It's working from the Pipulate built-in library. I'm accumulating the new clicks. It's doing a one-click depth crawl. And what we were doing back over here is happening all over again. Those sizes are back. You notice this is back up to something like 5K, and this is back down to something like 52K. And now we have the double feedback going on of those numbers changing and this output occurring. But I'm not going to make you sit through this. I'm just that confident that this is all correct. And now a one-click depth crawl is built into Pipulate that'll just spin through a site and get all the pages that are important to a site because you point the home page. And honestly, visiting every page that's linked to the home page to get all its links and to go and visit that subsequent page for its links is a pretty friggin' comprehensive crawl when you're trying to dig up the important links on the site, because there's hardly going to be anything that's important that publisher wouldn't put on a page linked from a page that's linked from the home page. So that's what this is getting. This is getting all the pages that are linked from a page that is linked from a page that's linked from the home page. A page that's linked from a page that's on the home page. I am not less perfect than you are. Okay. Thanks for joining me. Hope to stream to you again soon. Git commit. Why wait until it's finished? One click depth crawl. Now in Pipulate. Oh, the multi-page crawl. Git add multi-page crawl. Git commit. Added multi-page crawl notebook. Git push. Now all you people cloning off of GitHub will have it. Oh, yeah, well, you know what? That's only for the Python SEO portion of it. Commit one click depth crawl. Now in Pipulate. Git push. Setup 3.54, 3.55. Release. While that's going on, we'll go over here and just show it's still working, right? It's going to go on for a while. And we don't have to wait for it. And we can check on progress. Oh, look, that might be done. Wow. Yay, it's done. New links. And it only went up to 112. That's nice. And there they are. Check the length of that. Should be some 1700 links. Yay! Pretty awesome, right? Scrapey for crawling. For simple crawling stuff, I mean, you know, I spent less time writing this than figuring out the, you know, complex support every edge case API of a super crawler package. Now, more power to them. I mean, it's nice sometimes to have all that capability, but it's also nice sometimes to just do lightweight crawls of a site, pull back everything you need just right there in that one sitting bippity boppity boo. Thanks for joining me. Hope to stream to you again soon. And don't forget to follow. Bye-bye.